Hi guys, this is a video by Darklink Does Math. The content in this video is geared towards 6th grade math standards. These videos are public so that my students may access this information easily, as well as anyone else looking for math help. I hope you find this video helpful. If you do not, I hope you can find what you are looking for elsewhere. There's a lot of information out there. Be aware that I am not perfect, so there may be the occasional mistake. I apologize in advance if this should happen. So today, we are going to go over lesson 1.3, part 2, which covers cubes. More specifically, cubes of numbers, or how to find the cube of a number. We're also going to go over the order of operation and go over a few examples of those. So our first term is cube of a number. Cube of a number refers to a value of a number raised to the third power. Value of a number raised to the third power. An example of this, our first one, we have 2 to the power of 3. We can also refer to this as 2 cubed. So 2 to the power of 3, 2 to the exponent of 3, or 2 cubed. What does this mean? That 3 tells you to write 2 3 times and then multiply. So 2 times 2 times 2. In this case, 2 times 2 is 4, 4 times 2 is 8. Another quick example, 3 to the power of 3, or 3 cubed. The exponent of 3 tells you to write the base 3 times. And then multiply. 3 times 3 times 3. In this case, 3 times 3 is 9. 9 times 3 is 27. One more quick example. 5 cubed, or 5 to the power of 3. The exponent of 3 tells you to write the base 5 3 times. And then multiply. So 5 times 5 is 25. 25 times 5, 25, 50, 75, 100, 125. So again, cube of a number means take a value or take a number and raise it to the power of 3, meaning multiply that number by itself 3 times in a row. This is not the same as multiplying by 3. So 2 to the power of 3, did we multiply by 3 anywhere? No. 3 to the power of 3, did we multiply by 3 anywhere? Well, yes, because our base was 3. Here, 5 to the power of 3, were we multiplying by 3? No. Your exponent of 3 simply tells you how many times to write your base. That's not what you're actually multiplying by. So keep in mind, when raising something to the power of 3, do not multiply by 3. Unless your base is 3, in which case you will. Just make sure you're multiplying it enough times. Our next term is perfect cube. Perfect cube is the cube of a whole number. Now, if you watched my previous video over squares, I recommended that it would make your life easier in math if you were to memorize the first 12 perfect squares. On this one, for cubes, I'm going to say it might make your life easier if you can memorize the first 10 perfect cubes. So I'll give you the first few and tell you how we can get them. So our first perfect cube is 1. Our next one is 8. Our third perfect cube is 27. Our fourth perfect cube is 64. And the list goes on and on. Now, where do we get 1? Well, if a perfect cube is the cube of a whole number, first one, 1, must be 1 to the power of 3, or 1 times 1 times 1. 8 is our second perfect cube. So we get that from taking 2 to the power of 3, or 2 times 2 times 2, and so on. 3 cubed will give us 27, 4 cubed will give us 64, 5 cubed would give us 125, and so on. Our last term is numerical expression. A numerical expression is a collection of numbers and operation symbols that represent a single value. A quick example of what a numerical expression might look like would be 10 cubed, or 10 to the power of 3, minus 4 squared, or 4 to the power of 2, times 5 squared, or 5 to the power of 2. We have a collection of numbers and numbers and operation symbols, such as minus, times, and our exponents. And if we were to solve this, we're going to get one single number, or one value. Okay, let's discuss cubes first. So our first problem is about finding volume. Volume is a very common use for cubing numbers. So in our first example, we have a cube. It has edges that are each 4 centimeters long. And we're going to find its volume. Now, what is volume? Volume means how many cubes you can fit inside a solid. So again, volume means how many cubes you can fit inside a solid. So, our example here, we basically want to know how many cubes will fit inside of this cube or solid. Our sides are 4 centimeters long. Our traditional formula that we would use would be volume equals length times width times height. So I'm going to introduce a new formula that you can use, and again, this would only work for cubes. Well, if you think about your length, width, and height, they're all the same, right? And again, this is only for cubes. Well, if the length, width, and height are the same, I could basically call them all the length. So, instead of length times width times height, I could basically say L times L times L. And I'm going to switch to capital L so they don't look like ones. Now, when you write something 3 times in a row and multiply, you are basically cubing a number. So if we look at our examples up here on our first vocab term, I wrote 3 3 times. That means 3 to the power 3. Here I wrote 5 3 times and multiplied. That's the same thing as 5 cubed, or 5 to the power 3. So here I have length 3 times in a row. We're multiplying. So our new formula that you can now use for volume of cubes, this won't work for rectangular prisms, triangular prisms, or any other type of objects, but you could say volume is equal to L cubed, or length to the power of 3. In other words, take your length and multiply by itself 3 times. Alright, so we're going to use this new exciting formula. You could technically use length times width times height, of course, but it's just not as exciting. So let's do volume equals length to the power of 3. So what is our length? Our length is 4. So we're going to write volume equals, we're going to replace length with 4, keep our exponent of 3. So volume equals, what does 4 to the power of 3 mean? It means write 4 3 times and multiply. 4 times 4 is 16. 16 times 4 is 64. Now, what is my label? Well, since I'm doing volume, and volume is all about how many cubes you can fit inside a solid, I'm saying that you can fit 64 tiny little blocks or cubes. What size? Centimeter size. So we can fit 64 1 centimeter by 1 centimeter by 1 centimeter cubes in this solid. So what would that kind of look like? Well, if you could imagine sorry about my horrible drawing. Oh, I've already messed up. All right. There we go. A little better. I shouldn't be using pen for this. So imagine this bottom layer of cubes, and we would stack more on top. You're eventually going to be able to fit 64 of those inside. So that's what volume means. How many cubes will fit inside a solid or in an object? In this case, our answer is 64 of them. Okay, let's just do some straight up cube examples. So our first, or example number 2, says find the cube of 7. What does the cube of 7 mean? It means 7 raised to an exponent of 3 or to the third power. That 3 tells you to write the 7 3 times. So 7, 7, and 7. And now we're going to multiply. So 7 times 7 is 49. And now we need to do 49 times 7. So here we're probably going to need a little bit of extra work. So 49 times 7. 7 times 9 is, lost my head, 63. I knew that. 7 times 4 is 28. We're going to add 6 and get 34. So 343. Is what 49 times 7 is. So 7 cubed, or 7 to the power of 3, which means 7 times 7 times 7 is 343. Now at this point, if you had that memorized, that the 7th perfect cube is 343, you would not have had to show all of that extra additional work. So in this case, having your first 10 perfect cubes might come in handy or be very helpful to you. All right, let's do one more example. 8 to the power of 3. If we were to write this in words, it means to find the cube of 8. So the cube of 8, or 8 cubed, or 8 to the power of 3, there's lots of different wordings for it. Again, that 3 tells you to write down 8 3 times and then multiply. So first, 8 times 8, 64. And now we still need to multiply by 8. If only I had my 8th perfect cube memorized, I could go ahead and just write our answer. But I don't have it memorized, so I'm going to have to show additional work. So 64 times 8. 8 times 4 is 32. 8 times 6 is 48, plus 3 is 51. So we get 512. So 8 to the power of 3, or the cube of 8, is equal to 512. So again, quick, or in review real quick, to find the cube of a number, you simply take a number and multiply it by itself 3 times. So 2 to the power of 3 means 2 times 2 times 2. 3 to the power of 3, 3 times 3 times 3. You are not multiplying by 3 unless your base is 3. All right, let's go over the first 10 perfect cubes. So these are these quick facts that you really should have memorized. It's going to make your life in math a lot easier if you have these memorized. They're a little bit harder than squares. So our first one comes from taking 1 to the power of 3, which means 1 times 1 times 1. That's 1. That's our first perfect cube. Our second one, 2 to the power 3, means write 2 3 times and multiply. 2 times 2 is 4. 4 times 2 is 8. So 8 is our second perfect cube. Our third one, 3 to the power 3, or 3 times 3 times 3. 3 times 3 is 9. 9 times 3 is 27. 27 is our third perfect cube. 4 to the power 3, or 4 times 4 times 4, you're going to get 64. Our fifth perfect cube, 5 times 5 times 5. 5 times 5 is 25. 25 times 5 is 125. Our sixth perfect cube, you would need to take 6 to the power 3, or 6 times 6 times 6. You're going to get 216. For the seventh perfect cube, take 7 to the power 3, which means 7 times 7 times 7. And you're going to get 343. Our eighth perfect cube, 8 times 8 times 8, you're going to get 512. For the ninth perfect cube, 9 times 9 times 9, you're going to get 729. And for the 10th perfect cube, you're going to do 10 times 10 times 10. You're going to get 1,000. Now, if you saw my previous video on squares, I mentioned that exponents next to zeros, you can use a shortcut. That exponent tells you how many zeros to write in your answer. So essentially, we're doing 1 times 1 times 1. And since that exponent of 3 is right next to a 0, it means write 3 zeros. So, quick little shortcut with zeros. So, if you memorize these first 10 perfect cubes, 1, 8, 27, 64, 125, 216, 343, 512, 729, and 1,000, it's going to make your life a lot easier in math. All right, let's move on to order of operations. So, order of operations follows 4 very specific steps. The first step in the order of operations is P, which stands for, or means, solve inside parentheses. What do parentheses look like? Well, they look like this, or we might refer to them as brackets, like that. Once you have finished everything inside parentheses, you get to move on to the second step. The second step of order of operations states that you must solve all exponents. So, in 6th grade, you're only going to be dealing with numbers that are squared or cubed. So, to the power of 2 or to the power of 3. Once you have done all parentheses and all exponents, you get to move on to the third step. The third step states that you need to multiply or divide. Multiply or divide. I would keep from thinking of it as multiply and divide, because that makes you think that you need to multiply first and then divide second. Absolutely not. You need to multiply or divide. How do you know which one to do first? You work your way left to right. And we're going to show you an example of that in just a second. So, if you see multiplication on the left, you're going to multiply first. If you see division on the left, you're going to divide first. So, it's whatever you see, multiplication or division, work your way left to right. Once you have done parentheses, exponents, multiplied or divided left to right, your fourth and final step is to see if you have any addition or subtraction. So fourth step is to add or subtract. And again, it's best if you think of this as an or instead of and. If you think of it as and, you might think that you need to add and then subtract in that order. Absolutely not. You're going to add or subtract. So you might add first, you might subtract first. How do you know which one to do first? Just like multiplication or division, you work your way left to right. Real quickly, what are multiplication signs going to look like? Either that, or we use the multiplication dot. Division, you might see a traditional division sign, or what looks like a fraction bar. Fractions do mean divide. Adding and subtracting. There's our addition sign, there's our subtraction sign. So these are some of the operation symbols you might encounter. Okay, let's do just a few examples on showing multiplication or division and addition or subtraction. So for multiplication or division, let's say I have 4 times 4 divide by 2. And let's say I have another example that's 4 divided by 4 times 2. Let's do the first example. I see multiplication and division. So which one do I do first? Well, our steps say that you must work left to right. So I see multiply first. So I'm going to do my multiplication first. 4 times 4 is 16. And then I'm going to divide by 2. 16 divided by 2 is 8. Now let's look at this example. In this example, we have division first and multiplication second. How do I know which one to do first? Well, it says multiply or divide left to right. So I have to start on the left and do 4 divided by 4 first. 4 divided by 4 is 1. And then I'm going to multiply second. 1 times 2 is 2. So identical numbers. However, I switched the signs just to show you that when multiplying or dividing, always work left to right. The same thing applies to addition or subtraction. So our two examples are going to be 3 plus 2 minus 1 and 3 minus 2 plus 1. So in the first example, I have addition and subtraction. Which one do I do first? You must work your way left to right. So I have to start with addition first. 3 plus 2 is 5. And then I'm going to subtract second. 5 minus 1 is 4. In the next example, I have subtraction and addition. I'm going to work my way left to right. So I have to do subtraction first this time. 3 minus 2 is 1. And then I'm going to add second. So 1 plus 1 is 2. So basically what I'm saying is be sure that you do not multiply first and divide second. And do not add first and subtract second. I'm telling you that you need to do whatever you see first. So if you see multiplication first, do multiplication first and then your division. If you see division first, do division first and then your multiplication second. Work your way left to right. Again, make sure you're following the overall order of operations. So if you see parentheses, you're going to have to work inside those parentheses before you do anything else, and so on. All right, let's do a few example problems. Our first one, 3 squared plus 4 squared. First step, are there any parentheses? Absolutely not. Second step, solve all exponents. Do I see exponents? Absolutely yes. So 3 to the power of 2. Whenever solving numerical expressions, make sure you're writing answers on each line. If you have any additional work to show it off to the side. So if you need to jot down what 3 to the power of 2 means, do it over here on the right side. Like 3 squared means 3 times 3, because the 2 tells me to write the 3 2 times. And 3 times 3 is 9. So here, right below 3 squared, I write my answer, 9. Now I'm going to do it the same with 4 squared. 4 squared means 4 times 4. 4 times 4 is 16. So I write my answer right there. And I'm going to bring down my addition sign. Whenever your equations are larger, you're going to need to make sure that you go through the whole process over and over just to double check. So are there any parentheses? No. Are there any more exponents? No, I did them all. Is there multiplication or division? No. Is there addition or subtraction? Yes. There's only one thing to do, addition. 9 plus 16. 9 plus 16 is 25. We have a single value. So we are finished. So keep in mind, work stays off to the side. Show your steps line by line underneath the problem. All right, we're going to skip over here to number 4. 5 cubed minus 4 squared. So if you have your perfect cubes and perfect squares memorized, you're not going to have much work to show off to the side. So if I'm doing 5 cubed and I have it memorized, I could simply write the answer. All right, before I get ahead of myself, let's just double check our steps. First step, parentheses, nope. Second step, exponents, yep. 5 cubed is 5 times 5 times 5, which is 125. Again, if you want to show work, show it off to the side like this. But if you have it memorized, no need to do that. All right, next, bring down our signs exactly where they are. And last, 4 squared, which means 4 times 4. It's going to be 16. Last step, we only have one subtraction problem, but it doesn't hurt to be in the practice of just quickly and instantly going through these steps. Do I have parentheses? No. Do I have exponents? No. Do I have multiplication or division? No. Do I have addition or subtraction? Yes, I have subtraction. 125, take away 16, you get 109. I now have a single value. That is our answer. All right, to number 2, the one we should have done. We have 7 to the power of 2 times 2 to the power of 2 plus 3 to the power of 3. First step, are there parentheses? Nope. Second step, are there exponents? Yup. So let's solve all. 7 to the power of 2 means 7 times 7, which is 49. Going to bring down our multiplication symbol. Next, 2 to the power of 2 means 2 times 2. That's 4. Going to bring down our addition sign. 3 to the power of 3 means 3 times 3 times 3. Again, sometimes it might help if you write them off to the side just to remind yourself that that's not 3 times 3. It's 3 times, in this case, which is 27. All right, next step. Go back through our process super quick. Are there any parentheses? No. Are there any exponents? Oops, sorry. No, no more exponents. Is there multiplication or division? Yes. I see multiplication. I must do it first. Do not add. I know adding is easy, but you must multiply first because multiplication comes before addition. So 49 times 4. All right, let's show a little work off to the side where it belongs. So 49 times 4. 4 times 9 is 36. 4 times 4 is 16, plus 3 is 19. 196. Bring down our plus, bring down the 27. Are there parentheses? No. Exponents? No. Multiplication or division? No. Addition or subtraction? Yes. What's 196 plus 27? Let's see. 223. All right. Let's move on down to example 3. We have 10 cubed minus 4 squared times 5 squared. First step, are there parentheses? Nope. Second step, exponents? Yep, 3 of them. 10 to the power of 3, 10 times 10 times 10, 1,000. Bring down our minus sign. 4 squared, or 4 times 4. 4 times 4 is 16. Bring down our multiplication symbol. Last, 5 squared. 5 times 5. It's going to be 25. All right, next step. Go through your processes again. Are there parentheses? Nope. Are there exponents? Nope. Is there multiplication or division? Yes. Multiplication. So we must do 16 times 25 first. Do not subtract. Our order of operations clearly say that you must multiply or divide before addition or subtraction. You don't do what you want to do. You have to follow the steps. All right, so 16 times 25. Let's do that over here real quick. 6 times 5 is 30. 6 times 2 is 12. 13, 14, 15. If I add that 3 to it, cross out the 3, we're done with it. Now I'm in the second column. I'm about to start multiplying the 1. So we're going to add a 0 to push ourselves over in that place value right there. 1 times 5 is 5. 1 times 2 is 2. Last step, add. 0 and 0 is 0. 5 and 5 is 10. 2, 1, and the 1 we carried is 4. 400. All right, we need to bring the 1,000 down in front because that's where it was. Bring down our subtraction sign. Again, you should quickly and mentally be going through your steps. Parentheses, no. Exponents, no. Multiply or divide, no. Addition or subtraction, yes, there's subtraction. 1,000, take away 400, it's going to be 600. All right, our last order of operations example, we've got 10 cubed divided by 4 squared times 4 squared. This one's going to have a little bit of work to it. So first step, go through your processes. Are there parentheses? No. Exponents? Yes. 10 times 10 times 10, 1,000. Bring down divide. 4 squared means 4 times 4, 16. Bring down times. 4 squared again. 4 times 4. It's going to be 16 again, obviously. Okay, now, do I multiply or divide? Well, there are no parentheses, no exponents, so yes, we multiply or divide. Which one first? Well, I have to work myself left to right. That means you have to do 1,000 divided by 16 first. That's going to be interesting. All right, let's do that off to the side over here. 1,000 divided by 16. We're going to have some decimals on this. So if you're practicing long division and we have remainders, this is going to be a great example of having decimals in your answer. 16 will not go into 1. It's too big. 16 will not go into 10. Again, too big. 16 will go into 100. Now, how many times? Let's see. 16's close to 20. I can fit 20, 40, 60, 80, 100, about 5 of them. So way down here, let's just check 16 times 5. 5 times 6 is 30. 5 times 1 is 5. 6, 7, 8. I bet I can fit another. Let's do 16 times 6. 6 times 6, 36. 6 times 1 is 6. 7, 8, 9. 96. Oh, it's close. So that's what I want. 16 goes into 100. 6 whole times. 16 times 6, 96. We're going to subtract and get 4. I have a number to bring down. Bring it. So now I have 40. How many times will 16 go into 40? Well, I know 16 times 2 is 32. And that's as close as we're going to get. So 16 goes into 40 2 times. 16 times 2 is 32. We're going to subtract and get 8. Okay, we do not do remainders as r's anymore. So our remainder must either be a fraction or a decimal. We're going to go with a decimal today. So what do? Add a decimal right there, bring it up into your answer, and you can add a 0. It's like adding a friend. Don't we wish we could just do that anytime? All right, bring on down your friend, that 0. Now we have 80. How many times will 16 go into 80? Well, luckily, because I showed my work, I already know the answer. It's going to go in 5 times. 16 times 5 is 80. We're going to subtract and get 0 remainder just like we want. So 1,000 divided by 16 is 62.5, or 62.5. Now we still have to multiply by 16. Well, this is awesome. All right, so multiplying decimals. Notice I'm doing my work off to the side. I'm only leaving right here, line after line, for answers only. Okay, 62.5 times 16. We're going to write 62.5 first, multiply by 16 second. We do not line up decimals, we simply line up numbers. And then pretend the decimal is not there and just multiply like normal. So 6 times 5 is 30. 6 times 2 is 12, plus 3 is 15. 6 times 6 is 36, plus 1 is 37. All right, I am done with that 1 and that 3. Because we're in the second place value or position, we're going to add a 0. So every time I write an answer, it's going to be below that 1. So 1 times 5 is 5. 1 times 2 is 2. 1 times 6 is 6. We're going to add those. 0 and 0 is 0. 5 and 5 is 10. Carry your 1. 2, 7 is 9. Plus 1 is 10. Write your 0, carry 1. 6, 3 is 9. Plus 1 is 10. Now, our answer is not 10,000. Why? There was a decimal. Do I just bring the decimal straight down? No, absolutely not. Count how many numbers you have behind the decimal. There's one number behind the decimal. One number behind the decimal. Because there's one number behind the decimal in the whole problem, just that 5, just one number, that means I'm going to move my decimal left one place value. So there's one number behind the decimal in my answer. Yes, I know it looks like I brought it straight down, but we really didn't. We're going to do more multiplying with decimals in Chapter 3. In the meantime, just make sure you count how many numbers are behind the decimal in your question. And that's how many should be behind the decimal in your answer. Do not bring down decimals when multiplying. This is not how it works. Okay, let's write this answer. 62.5 times 16 is 1,000. And we are finished, and we're like, thank goodness. Although I'm kind of sad because math is really fun. All right, we have 2 more example problems to go over. Our example 6. We're going to find 2 consecutive numbers whose squares differ by 15. Now, there's an actual nice little method to do this. So first, let's go over what this means. 2 consecutive numbers. That means one number right after the other, like 1 and 2, or 4 and 5, or 7 and 8, or 9 and 10. We want to take their squares, and their difference is going to be 15. So what does that mean? I want 2 numbers whose squares will differ. Differ means difference or subtract. And that difference needs to be 15. There's a simple 2 or 3 step process to do this. First step, take your number and divide by 2. So we're going to do that right there. Our number was 15. So we're going to take 15 and divide by 2. What do we get? We get 7.5, or 7.5. Our second step, we're going to take the number right above and right below 7.5, and that will be your answer. So take the number right below and right above for your answer. So let's look at what that means. If I look at 7.5, what number or whole number is right below 7.5? 7. What number is right above 7.5 on a number line? 8. So that means 7 and 8 are our answers. Again, this was one below, and this was one above. So 7 and 8 are our answer, or is our answer. Now, I could check this to make sure. We really should check it. If I take 8 squared and subtract 7 squared, will I get 15? Well, let's see. 8 squared is 64. 7 squared is 49. 64 minus 49 is 15. So it works. So again, our answer is 7 and 8. So anytime you're looking for two consecutive numbers whose squares differ by 15, you could use this nice little method to come up with those. All right, our very last example, and then I'll be quiet. All right, find three consecutive numbers whose cubes have a sum of 64. So again, the idea is find three numbers in a row whose cubes, so to the power of 3, have a sum, which means addition, of 64, meaning our 64 should be our number. Oh my, that's a mistake. This really should say 684. I was like, that's not going to work. 684, my bad. Okay, now, there is no cute little method that works for this. Basically, you're just going to have to guess and check until you get it right. So what could speed this process up? Knowing your perfect cubes. So I'm just going to list out some. I know the first few perfect cubes are 1, 8, 27, 64, 125, 216, and 343. And I want three of them that go in a row that will add up to 684. Well, if I look and estimate, I would say 300, 400, 500, 600. I'm pretty close to that number. So I'm thinking maybe these three numbers right here. Well, how do I get those? Well, that's technically 5, 6, and 7 cubed. So let's try those numbers. If I try 5 to the power of 3 plus 6 to the power of 3 plus 7 to the power of 3, I want to know, will I get 684? Well, let's see. 5 to the power of 3 is 125. 6 cubed is 216. 7 cubed is 343. Let's add that up super quick over here. 125, 216, 343. 5 plus 3 is 8, plus 6 is 14. 4, 5, 6, 7, 8. 3, 4, 5, 6. Oh wow, it looks like it works perfectly. So it is 684. It works. So what does that mean our answer is? What three consecutive numbers, when you cube them, have a sum of 684, not 64? That would be the 5, 6, and 7. All right, again, I hope that this has helped you understand a little bit more about finding cubes of numbers. Just remember, cubing numbers does not mean multiply by 3. It means writing a value 3 times in a row and multiplying by itself 3 times in a row. When you're doing order of operations, remember to quickly go through each of your steps one by one. Check, are there parentheses? Are there exponents? Do you see multiplication or division? If so, do the first one you see, working your way left to right. And then last step, addition or subtraction. Again, whatever you see first, left to right, that's the way you work it. I hope this has helped. If it hasn't, I hope you can find another video out there that will. Y'all have a great day.